In this video, I will explain find the complex exponential Fourier series, Fourier series quotient of the figure shown below. And also determine Fourier series quotients, Fourier series quotients from complex exponential Fourier series quotient. This is the statement. The waveform is here waveform. This is the waveform. This is t-axis, x of t. Waveform is like that. Zero. This value is 1/2. 1. This value is 3/2. This value is -1/2. -1. -3/2. 2 and -2. These are the values. One. -1. First of all, time period of the waveform. Calculate time period of the waveform. This one is -1/2 to 3/2. Time period of the waveform is t0. This one is small t0 plus capital T. T0 is equal to -1/2. Small t0 plus capital T0 is equal to 3/2. Therefore, time period of the waveform is t0 is equal to 3/2 minus t0. That is 3/2 minus of -1/2. 3/2 plus 1/2, 4/2. That is 2. Time period of the waveform is 2. Here minus 1/2 to 1/2, the value is 1. 1/2 to 3/2, the value is -1. Here, this is the time period. After that time period, the waveform is repeated. Here, one by two plus 1/2, 1 plus 1/2, 3/2, 3/2 plus 1 is 2 here. Here -2. 2 plus 1 by 2. Here 5 by 2. This one is minus 5 by 2. This is the waveform. Time period of the waveform is raised like that. T naught, small t naught is minus 1 by 2. Small t naught plus capital T naught is 3 by 2. This one is 5 by 2 minus 1. So many ways you have to choose T naught value. This one is minus 1 to here minus 3 by 2 to 1 by 2. Minus 3 by 2 is T naught, 1 by 2 is T naught plus small t naught plus capital T naught. Therefore, 1 by 2 plus 3 by 2. Same result. According to exponential Fourier series coefficient formula, Cn is equal to 1 by T naught, small t naught plus capital T naught, x of t e power minus j n omega naught t dt. If small t naught is minus 1 by 2, small t naught plus capital T naught is 3 by 2. Split into two intervals, minus 1 by 2 to 1 by 2, 1 by 2 to 3 by 2. Here, time period of the waveform T naught is 2, small t naught is minus 1 by 2 to 3 by 2, minus 1 by 2 to 3 by 2, sub t e power minus a n omega naught is 2 pi pi t naught to t dt. That is equal to 1 by 2 minus 1 by 2 to 3 by 2 x of t e power minus a n 2 pi by t naught is 2 to cancel, minus 1 by 2 to here minus 1 by 2 to 1 by 2, minus 1 by 2 less than or equal to t less than or equal to 1 by 2. The value of x of t is 1. 1 by 2 less than or equal to 2 less than or equal to 3 by 2. The value of x of t is 1 by 2 minus 1 by 2 to 1 by 2 x of t e power minus a n pi t dt plus 1 by 2 to 3 by 2. 1 by 2 to 3 by 2 x of t e power minus a n pi t dt. That is equal to 1 by 2 minus 1 by 2 to plus 1 by 2. The value of x of t is 1 e power minus a n pi t dt plus minus 1 by 2 to 3 by 2. The value of x of t is minus 1 e power minus a n pi t dt. That is equal to 1 by 2 integral of e power minus a n pi t is e power minus a n pi t by minus j n pi minus 1 by 2 plus 1 by 2 plus minus e power minus a n pi t by minus j n pi t minus j n pi integral limits are 3 by 2 1 by 2. Here these are cancelled, minus is cancelled. Substitute the values in the above equation. One by two. Here 1 by 2. E power minus j n by 2 minus here minus j n pi. This is the upper limit is substituted. Lower limit, for lower limit minus of minus plus e power minus into minus plus j n pi t by 2 j n pi plus e power minus j n pi t is 3 by 2 j n pi here minus e power minus j n pi t is 1 by 2 by j n pi. This is the value. Cn is Cn value is like that. Cn value e power minus j n pi by minus j n pi e power j n pi t by 2 j n pi e power minus j n pi 3 by 2 j n pi minus e power minus j n pi 2 by j n pi. This one is Cn minus e power minus j n pi by 2 j n pi plus e power j n pi by 2 into t j n pi plus e power minus j n pi 3 by 2 by j n pi minus e power minus j n pi 2 by j n pi. C minus n. Suppose C minus n. Here n is replaced with plus n. E power n is replaced with minus n, minus into minus plus e power j n pi by 2 by here n is replaced with minus n, minus into minus plus 2j n pi. Here n is replaced with minus n. Here n is replaced with minus n. E power minus j n pi by 2 t j n pi. Here n is replaced with minus n. Minus e power, here n is replaced with minus n, minus into minus, minus into plus minus, e power j n pi 3 by 2 j n pi. Here n is replaced with plus minus n. Here minus n, minus into minus plus e power j n pi by 2 by j n pi. These are the C minus n. Cn minus C minus n. Here e power j n pi by 2 j n pi. C minus n is e power j n pi by 2 by j n pi. These two are plus minus. Cn, so the minus sign. Therefore, this one is the plus sign. This one is a minus sign. These two are cancelled. And here minus into minus plus e power j n pi 3 by 2 j n pi. Consider these two. Consider these two. Here minus sign, minus into minus plus. E power j n pi 3 by 2 by j n pi. J n pi. Here minus n. Here plus is plus same as to the so there. E power minus j n pi 3 by 2 j n pi. These two are completed. And here minus e power minus j n pi by 2. Here minus e power minus j n pi by 2 by 2 j n pi. Here 2 is there. Here 2. Here 2 is there. Because 1 by 2 term is there. Consider this term. And e power j n pi 2 by 2 j n pi minus the minus. This term also consider. Therefore, minus of here because the c minus n minus c minus n means minus here minus n. E power j n pi by 2 by 2 j n pi. Here minus sign is also there. We use bracket here. E power minus j n pi by 2 by 2 j n pi. 2 j n pi. Here e power minus j n pi by 2 j n pi minus of minus plus e power minus j n pi by 2 into t by 2 j n pi. These two are cancelled. These two are cancelled. Finally, Cn minus C minus n is equal to e power j n pi by 3 1 by the 2 term is also there because 2 term is also there. 1 by j n pi is common term in all the cases. E power j n pi in pi 3 by 2 by 2 plus e power minus j minus 1 by j n pi e power j n pi by 3 plus e power minus j 2 into 2 by 1 by j n pi cos n pi by 3 cos n pi by 3 minus cos here cos cos 3 n pi by 2. Here cos e power jx plus e power minus x by 2 is cos n pi by 3 n pi by 2. This is the Bn value. Bn is 1 by n by cos 3 n pi by 2 minus cos n pi by 2. This is Cn. Cn minus C minus n is equal to, we know that 1 by Jn pi cos 3 cos that is cos 3 n pi by 2 minus cos n pi by 2. This is the Cn minus C minus n. Cos 3 n pi by 2 minus cos n pi by 2. Cn is equal to, we know that Cn is equal to minus e power minus a n pi by 2 plus e power j n pi by 2. So here 2j n pi, here 2j n pi plus e power minus a n pi by 2, 2j n pi minus e power minus a here e power minus a n pi by 2 by 2j n pi, e power j n pi by 2 by 2j n pi, e power minus a n pi 3 by 2 2j n pi minus e power minus a n pi by 2 by 2j n. This is Cn. This is Cn plus or minus. C minus n is equal to minus n. N is replaced with minus n j n pi by 2 by 8 n is replaced with minus n to minus plus 2j n pi. Here n is replaced with minus n. Here n is replaced with minus n e power minus a n pi by 2 by 2j n pi. Here n is replaced with minus n e power j n pi 3 by 2 by 2j n pi. Here n is replaced with minus n e power j 2j n. Now calculate Cn plus C minus n. E power j n pi by 2 by 2j n pi minus e power minus j n pi by 2 by 2j n pi. Both are right here. E power j n pi by 2 by 2j n pi minus e power minus j n pi by 2 by 2j n pi. Here minus side, these two are completed. Here minus e power j 3 n pi by 2 by 2j n pi. Here minus into minus plus, that is the reason minus sign here. 2j n pi. Here j n pi by 2, these two are completed. E power j n pi by 2 by 2j n pi, e power j n pi by 2 2j n pi. That is two times occur. 2 into e power j n pi by 2 by 2j n pi. And similarly, these two are completed. And similarly, minus e power minus a n pi by 2 by 2j n pi. Here minus e power minus a n pi by 2 by 2j n pi. Minus 2 times. minus 2 into e power minus j 2j. This one 2 to cancel. Finally here 1 by n pi e power j n pi by 2 minus e power minus n pi by 2 by 2j e power j n pi by 2 minus e power minus j n pi by 2 by 2j minus 1 by n pi e power j 3n pi by 2 minus e power minus j n pi 3n pi by 2 by 2z. Here 1 by 2 to cancel here to 1 by j n pi e power j n pi by 2 is cos n pi by 2 plus j sin n pi by 2. Here minus j n pi is coming, e power minus j n pi by 2 is cos n pi by 2 minus j sin n pi by 2 minus into minus plus j sin n pi by 2. Cos n pi by 2 minus cos n pi by 2 is cancelled. 2j sin n pi by 2. That is 1 by n pi e power jx minus e power minus x by 2j is sin x. Sin n pi by 2 minus 1 by n pi. Here e power jx minus e power minus x by 2j is sin 3 n pi by 2. Here 2j sin n pi by 2. 2j sin n pi by 2 plus j sin n pi by 2 is 2j plus 2j sin. Here n is there. 2j sin n pi by 2 by j n pi. 2 sin n pi by 2. 1 by n pi. 1 by n pi is common term. 2 sin n pi by 2. Sin n pi by 2 is 3 sin n pi by 2 minus sin 3 n pi by 2. This is the Cn plus Cn. We know that according to formula Cn is equal to An minus jPn by 2. C minus n is equal to An plus jPn by 2. 2Cn is equal to An minus jPn. 2C minus n is equal to An plus jPn. These two are added. Therefore, 2C minus n is equal to An plus jPn. These two are added. 2 into Cn plus C minus n is equal to An. An is equal to Cn plus C minus n. Cn plus C minus n is 1 by n pi, 3 sin n pi by 2 minus sin 3 n pi by 2. 1 by n pi, 3 sin n pi by 2 minus sin 3 n pi by 2. This is A. And similarly, these two are here are 2 C by C n is equal to Cn is equal to An minus ABN, and 2C minus n is equal to An plus ABN minus. 2 into Cn minus Cn minus Cn is equal to An cancel minus 2j Bn j into j square j into j square minus 1 minus into minus plus 2 to cancel. Therefore, finally, Bn is equal to j into Cn minus Cn minus. Bn is equal to j into Cn minus Cn minus n. Cn minus Cn minus n is 1 by j pi n plus 3 n pi by 2 minus cos n pi by already derived Cn minus Cn 1 by j n pi cos 3 n pi by 2 minus cos n pi by 2. Here j term cancel, that is 1 by n pi cos 3 n pi by 2 minus cos n pi by 2. Now calculate C naught. C naught is equal to 1 by T naught plus T naught capital small t plus capital T naught x of t e power minus a n value e power j n omega naught t. Here n is equal to 0. N is equal to 0 means e power 0, that is 1. Here n is equal to 0. 1 by T naught small t naught plus capital T naught x of t dt. E power 0 is 1. We know that 1 by T naught is 2 minus 1 by 2 to 2 1 by 2 x of t dt plus 1 by 2 to 3 by 2 x of t dt. That is equal to 1 by 2 integral of 1 dt. Here minus 1 dt. Here 1 dt. 1 dt is t 1 by 2 to minus 1 by 2 minus into x. In that interval x of t value is minus 1. T 3 by 2 1 by 2. 1 by 2. Here 1 by 2 plus 1 by 2 minus 3 by 2 minus 1 by 2. 1 by 2, 1 minus 1 is 0. This is C naught is equal to A naught is equal to 0. Finally, AN is equal to 1 by n pi. 1 by n pi AN value is 1 by n pi 3 sin n pi by 2 minus sin 3 n pi by 2. 3 sin n pi by 2 minus sin 3 n pi by 2. Bn is equal to 1 by n pi cos 3 n pi by 2 minus cos n pi by 2. These are the Fourier series quotients. Substitute these Fourier series quotients in the expression x of t a naught sigma n is equal to 1 to infinity an cos n omega naught t sigma n is equal to 1 to infinity bn sin n omega naught. A naught is the C naught, that is 0. Therefore, sigma n is equal to 1 to infinity. An is 1 by n pi 3 sin n pi by 2 3 sin n pi by 2 minus sin 3 n pi by 2 into cos n 2 pi by t naught into t, and the sigma n is equal to 1 to infinity 1 by n pi. Bn is cos 3 n pi by 2 cos 3n pi by 2 minus cos n pi by 2. Sin n omega naught 2 pi by t naught into t. Here t naught is 2, to cancel here t naught is also 2, and please cancel. Finally 1 pi finally 1 by n pi sigma n is equal to 1 to infinity 3 sin n pi by 2 minus sin 3n pi by 2 cos cos pi 2 plus sigma n is equal to plus sigma n is equal to 1 to infinity cos 3n pi by 2 minus cos n pi by 2 sin pi 2. This is the final expression. Final expression of the Fourier series. If you like this video, please subscribe the channel for further updates. Thank you.